Palermo, Sicily. In this port city, a titan in the world of the shipbuilding industry is changing the face of the cruise business. Here, at one of the biggest dry docks in the Mediterranean, cruise ships are literally put under the knife. Some of the biggest vessels on the sea are cut in half and lengthened with an entirely new section, undergoing a new and complex process called Jumboization. Palermo, Sicily, buzzes with the intoxicating mix of cultures that is a result of its domination by the Greek, Roman, Arab and Spanish civilizations over the last 3,000 years. Famous for the influence of mafia gangsters, it's also heralded across the globe for its beautiful beaches, breathtaking scenery and complex history. Palermo is not only a well-visited location for tourists, it is a major Italian trading port. Dawn rises at the construction site where Fincantieri engineers and ship experts are hard at work, moving tens of thousands of metric tons with near-laser precision.
We're cutting a ship that's 28 meters wide with a height of 50 meters from the bottom to deck 11 with a tolerance of just a few millimeters.
Overall, the Fagioli skid shoe system has raised 15,000 metric tons.
After the enlargement of the ship, she will have an added capacity of about 500 passengers.
Making even bigger ships is big business. This construction site is owned and operated by Fincantieri, which builds some of the largest ships across the globe. Fincantieri is in the business of constructing cruise ships, barges and military vessels. Here in Palermo, the company has pioneered a ship recycling program to meet demand for bigger and bigger vessels for the lucrative cruise industry. In the process, they have created a thriving new market for upgraded ships. The Renaissance program is a massive engineering project, the lengthening of 4 ships for Mediterranean Shipping Company, MSC. Each of these 4 ships, the MSC Armonia, Sinfonia, Opera and Lyrica, are undergoing the Jumboization process, due to be completed by the end of 2015.
The repairs and enlargement division that does what you can see behind me is just one of the divisions of Fincantieri.
The shipyards here in Palermo have got the technique down to a fine art. The tools used to lengthen a ship, once cut in half, are massive movers. Skid shoes are like a hydraulic train that moves along steel rails on which the carriages are pushed horizontally by hydraulic levers acting on the sleepers. The skid shoe system is computer-controlled and powered by diesel fuel packs. Each unit has the capacity to lift more than 1,000 metric tons. These particular skid shoes are a brand new design by the Fagioli engineering department. Before the Jumboization process in the Palermo docks, Fagioli delivered into the yard no less than 22 skid shoes and built 3 rails to hold the wide hull of the cruise liner as it was being cut in 2. The weight of the front half of the ship is supported by vertical cylinders, and each skid shoe is able to support 1,000 tons. Getting the ship resting on skid shoes, however, involved a lengthy preparatory process. First, the dry dock had to be emptied using massive pumps. The operation took a whole day. Once the dry dock was empty, the skid shoes on which the ship's hull would rest and then be pulled apart, once sliced through, had to be positioned at the bottom of the dock and the electrical parts removed before the dock was flooded. The amazing process of jumboization starts with the creation of the new segment of the ship that has to be positioned in such a way that on the big day, the whole process goes according to plan. In May 2015, the Fincantieri yards successfully floated a new segment that was to be used to lengthen the MSC cruise liner Opera. The new segment, specially built to lengthen the ship, was first ceremonially floated, proving that it would contribute to the buoyancy of the lengthened ship, and then positioned in the dock where the massive Opera was to rest for the time of its complex, high-tech lengthening surgery. Filippo Oddo is the Fincantieri yard director and has been working on the jumboization of ships in Palermo, Sicily for decades.
This dry dock has a capacity of 400,000 cubic meters. It's one of the biggest in the Mediterranean Sea. To give you an idea, its surface is 4 football pitches in length. It allows us to do this process that we're doing because it is wide enough, as I've said before, to allow the new section to be moved next to the ship. If it were narrower, we could not do this. This is the reason why we used this dock in the past as well, for this kind of operation.
Once all was ready, the dock could be filled again, slowly so as not to move the skid shoes. As soon as the dock was full, the massive cruise ship could be sailed in. It was carefully positioned over the skid shoes, and the dry dock was emptied once more. The ship and the new segment slowly sank to the bottom of the dock, and the ship rested snugly on the skid shoes that would become its operating table.
The first thing we did in the dock before the ship arrived at the dry dock was to put the skid shoes in place. That's before the ship arrived. At that point, the dock was flooded, so the skid shoes were submerged underwater. Thanks to this, the ship could be sailed into the dock and positioned onto the skid shoes as the dock was emptied. At this point, once it was settled, the dock was completely emptied of water until dry.
This is an operation that has been done many times in these yards, a speciality developed here since the 1980s.
The Palermo yards has a lot of experience. The first enlargement process was done in 1980 to lengthen the Ville d'Anvers, and over the years we have done several others. This enlargement process of the MSC Opera is the 27th operation in this series. The next will be applied to the last of the 4 MSC ships in the Renaissance program with the MSC Lyrica. It will close the cycle of the enlargement of MSC ships.
The MSC Opera is 251.25 meters long and 28.8 meters wide, and when fully operational, hosts 2,199 passengers, offering 878 cabins and suites, luxury bars, a theatre, a casino, shops, and many other attractions. With a new segment slotted into the middle, the capacity will increase to 2,700 passengers, which means that the ship will have to carry more food and offer yet more services. It is just one of the hundreds of massive cruise ships that grace the ocean waves, offering vacations to a market of 22.2 million people, with a turnover of $39.6 billion. It is a growing tourism segment, but not without its own safety issues. On the 13th of January 2012, the giant cruise ship Costa Concordia crashed into the rocks off the island of Giglio in the Tuscan archipelago, leading not only to the world's largest ever ship salvage operation, but also to criminal and civil trials in which the safety of these mega ships was questioned. American lawyer John Eves was one of the most outspoken critics of the cruise industry.
You know, this industry has continued to just grow bigger and bigger and bigger. Costa Concordia is not even the largest ship. The largest ship is a 6,000 passenger vessel. The problem here is that these ships are top heavy. They do this for profit because they know that they can sell a balcony space for much more than they can sell space under or below the waterline.
However, Fincantieri shipbuilders say tests on the structural integrity of the ships they have stretched prove that these ships are not weakened by jumboization.
Safety is not an issue in ship lengthening. The lengthened ship has to satisfy strength criteria and resistance to stresses that it will encounter during its life at sea, exactly like any other ship. So from the resistance point of view, it makes no difference whether this is a lengthened ship or a ship originally built with these dimensions.
Che questa sia una nave allungata o sia una nave appena costruita di questa lunghezza non c'è alcuna differenza.
Fincantieri has just delivered one of the 10 largest cruise ships in the world to its clients, Princess Cruises. The Regal Princess and other massive liners regularly come off the production line at these types of shipyards around Italy, from Trieste to Palermo.
If you were to compare the construction work we do here at the Palermo site with the construction of new ships, the first thing you would notice is the timing. To construct a new ship, from the very beginning to when it's ready to take to the sea with passengers, would take at least 2.5 years. Here we estimate, even when taking into consideration the work of engineers, that we can finish the ship in 9 months.
All'inizio si esaurisce in 9 mesi.
The jumboization process cuts down on costs, resources, and the years of labor that it would take to build new cruise ships. The current series of 4 cruise ships that Fincantieri is working on will cost 200 million euros when complete. That's just a fraction of the cost of building a single new cruise ship like the Regal Princess, which carries a price tag of up to €1 billion. Stretching an already massive liner takes equally huge lifting and pulling machines. This is the MSC Opera, one of the finest cruise ships to sail the seas, built in 2003 in Marseille, France. That just 10 years after launch, she is ready to be lengthened to host yet more passengers is an indication of how fast the cruise industry is growing. She is about ready to go under the knife here in the Palermo dry dock. Engineers and technicians are tightening the cables and positioning the skid shoes that hold her in place as preparations get underway.
She is about 250 meters long, and after it's all finished with the lengthening process, she will be about 275 meters long. The new section is about 25 meters long. The beam remains the same, of course, and is about 29 meters.
The MSC Opera is 59,058 gross tons, which refers not to its real weight, but to its cargo transport capacity, and so its potential commercial value, while the ship's dry weight is the weight that the skid shoes have to lift and carry. Transport company Fagioli supplied Fincantieri with skid shoes and trailers to do this heavy lift job. The team on site is led by Loris Giovannini.
The skid shoe system combines both lifting and transport. The lifting function is done with hydraulic jacks, which take on the vertical weight and are therefore able to provide vertical lift. The skid shoes also have another hydraulic system that allows them to apply a horizontal sliding action.
Once settled in the dry dock, the engineers ordered it to be cut in two and prepared for the new midship block to be inserted. The new segment was built in the Fincantieri yards over the past 5 months so as to keep the Opera working on the cruise routes while it waited for its mega stretch. Building a new chunk of ship to add to a vessel that was not built here was problematic. But before Fincantieri could begin construction on a new midsection, they had to be absolutely sure of the ship's measurements and specifications. For this, they had to go back to the original plans and technical documents of the ship. Andrew Toso is the project manager in Fincantieri's Palermo site. He is looking over the vessel's technical documents to be absolutely sure of its measurements and specifications. He oversees the logistics behind the massive Jumboization operation and makes sure that things run smoothly, with over 100 workers on the job.
The operation starts with the examination of technical documents that were made by the ship builder. This is a ship that wasn't constructed initially by Fincantieri, so we have to ask the ship's owner for the technical documents in order to start the project.
Obviously, before the ship arrives, the construction site has already completed construction of the ship's new section, and this new section is completed in every way: the ventilation system, the electrical wires, the cabins, the bathroom boxes. It will be completely finished so that in the end all we will need to do is connect the forward and rear faces of the new segment.
Only once we've seen the documents can we start our part of the project. So on the basis of those documents, we've shaped our project. But before we can begin constructing the new section. And as we've said, tolerances can be compared to a single blade of grass against a whole football pitch. We can't just sort of guess or hope that the original plans are sufficiently precise and don't need to be verified before construction. So once we've put together the preliminary documents, we go on board to carry out final checks to validate the initial data, and only then can we put together the whole project.
The new section was fitted with all the necessary specifications so that the ship would be continuous from bow to stern. The new section was 25 meters long. Each ship gets a custom-made segment to insert. It's not just the metal plates, beams, and frames that need to be cut. A cruise ship like the Opera is connected together by a maze of electric wires, hydraulics, plumbing, and ventilation ducts that need to be sliced and rebuilt.
In addition to cutting the beams and decks of the ship and the whole of the ship, all the wires that run throughout the ship are cut on the same line. The electrical wires will need to be reconnected so as to run through the entire ship, and they will be tagged with a code to enable this connection. We're talking about around 2,000 wires that are cut, marked, and then reconnected. The same happens with the pipes and the ventilation conduits.
Lo stesso accade per le tubazioni, lo stesso accade per le condotte di ventilazione.
Like every ship, first the double keel was laid, and then, as it grew before the eyes of the engineers that built it, it assumed the qualities of a viable floating vessel. The new section was built to the same specifications as the ship it would go into. And of course, the construction materials and tools were state-of-the-art, light and transportable. It took about 5 months to complete the segment, with the utilities and furnishings that matched the rest of the ship. At the end of construction, it was duly blessed in the presence of the local authorities. The new section of the ship was fitted with the 2,000 electrical wires and plumbing pipes so that when the ship was extended an extra 25 meters, all of the systems would connect.
The ship before enlargement has a gross tonnage of 60,000 tons, and after it's enlarged, it will be 65,000 tons. In terms of displacement, so the real weight of the ship will be from 30,000 tons to 32,500 tons. The whole extent of the increased weight comes from the new section.
In that 5 months, the new section was completely outfitted with carpets, cabins, and bathrooms. The Jumboization process is fast and efficient, so the ship can be returned to commissioned service as soon as possible.
Anche per il taglio lo possiamo dividere in due fasi.
Also, for the cutting of the ship, well, we can split it up into 2 phases. All the preparations for lighting the blowtorch and cutting the ship start when they remove all the fittings. When we say fittings, we mean the cabins, the beds, the mattresses, the bathrooms, the carpets. Once all these things are all removed, we get down to the raw metal of the ship.
E quindi si scopre il ferro nudo.
Once the ship was stripped to its iron frame, metal workers marked a precise plan for cutting the ship. By referring to the original technical documents of the vessel, experts measured the plating and beams in order for them to be cut with precise laser accuracy. A physical mark was made on the cutting line where metal workers would go in with blowtorches and melt the metal apart. After this process, Opera was ready to be stretched, sitting snugly in the massive dry dock of Palermo, Sicily, resting on skid shoes that not only took the load, but also would later be used to move the bow and stern sections of the ship apart.
The side of the ship, or actually all the flat surfaces, are cut semi-automatically. There are machines that are positioned so that the cut can be carried out automatically using normal acetylene torches, basically with the same acetylene blow torches that are very common. The curved parts of the ship, the round, bulbous parts, are cut by hand by experienced metal workers.
Not all the areas that need to be cut are easily accessible. Some of the spaces are very cramped, but workers squeeze together and work for hours to finish the project on schedule.
The number of people needed on the ship depends on how many people can work in the same space without interfering with each other. Also, because the ship isn't just randomly cut. To be able to preserve the ship's structural integrity, it's cut in a special sequence. You can't just attack the ship's decks and plates simultaneously. So basically, we have about 40 people all cutting a particular section at the same time, and that process should usually take around 4 days.
E l'operazione dura mediamente 4 giorni.
As the sun set over the port of Palermo, the dry dock was abuzz with workers ready to perform a massive nighttime stretching operation. The MSC Opera was about to undergo an incredible upgrade in this huge dry dock construction site where it had been cut in half. Workers had verified the original technical documents of the ship and were about to proceed with the first stages of Jumboization. After these checks, they could be certain that the new section would fit into place with absolute precision. The bow of the ship slid forward, ready for operations the next day. Once lengthened, she would be able to sail the waters with as much ease and with the same fluid dynamics and physics as she had as a shorter ship. The Italian company Fagioli works all over the world, providing heavy lifting services for both commercial marine and land operations. Fagioli and Fincantieri have taken on a massive lift project together to stretch a cruise liner. While jumboization sounds simple in theory, lifting and transporting these massive loads is a complicated job.
Fagioli became involved in the jumboization process that consists of cutting the ship in half in 2 sections. One of those parts was then supported by the Fagioli skidding system that proceeded to move it 28 meters. This task was combined with another lifting system, the SPMTs, to insert the segment between the 2 extremities. Once this additional segment was added, the part of the ship that had been skidded 28 meters was then moved back.
4 days after the ship was cut in half, the Fagioli skid shoes began their slow work. Engineers made sure that the skid shoes were working at the same speed, so as to provide an even force along the whole hull. It took 6 hours for a gaping hole to appear on the ship, where the new segment could be slipped in over the next day.
When the cut was completed, we began operations and took the weight of the ship on the skid shoes, and the bow of the ship was lifted. With 22 skid shoes, with a 1,000-ton capacity each, in all, the Fagioli skidding system lifted 15,000 tons.
The 2 most critical technologies that Fagioli provided for the Jumboization project were the skid shoes and the SPMT transportation and lifting machines. SPMT stands for Self-Propelled Modular Transporter. They are specialized trailers that allow for the distribution of heavy weights over a large area. They are used worldwide for moving oversized, non-detachable superstructure cargoes. They have a powerful engine and hydraulic pumps and must have fast response for synchronized steering and lifting.
Both systems that we've utilized in our operations here, the skid shoes and the SPMTs, guarantee all of the 6 degrees of freedom. So they allow obviously the horizontal advancement, the transverse movement, and also, as we've said before, vertical lift.
SPMTs like these are widely used all over the world for this ability to position heavy loads with all 6 degrees of movement. It's one of the few technologies that can position these loads in tight spaces. A single operator can control the SPMTs, lifting and lowering heavy loads vertically as well as moving them forward, in reverse and side to side.
On top of all that, they allow for the rotation with respect to the 3 axes. All the different directions of movement are covered by the systems we are using. The purpose of all this is to make sure we can align the additional section with the MSC ship's sections with millimetric precision.
SPMTs can carry a load of over 10 metric tons per square meter. This ability to hold a mass distributed over a large area is crucial when transporting loads so heavy they can crush the ground and crack the concrete underneath.
We can move huge structures, offloading very little weight onto the ground, so keeping within the boundaries of what the surface can sustain.
Although the SPMTs can take a uniform weight distributed across a large area, they also have the ability to be taken apart, so that each axle is its own individual unit. The separate units can be locked together from the front and the back to build an individual train-like transportation system, or they can be locked side by side to allow for extra strength and stabilization.
The SPMTs can be placed together, both one in front of the other and also side by side. For today's operations, we can put together 80 axles. The weight of the new section was too large for the SPMTs to be able to move it, so we chose the skidding system, utilizing the skid shoes. Meanwhile, the additional segment had a relatively low weight, so we could use the SPMTs alone.
Motivo per il quale è stato utilizzato il carrello semovente.
The MSC Opera sits in the dry dock of the bustling Italian port city of Palermo. The ship has been cut and the bow moved forward 28 meters. However, before Andrew Tozo gives the order to insert the new section, the yard takes advantage of the gap in the ship to fill it with fittings that otherwise would be too large to be inserted through the existing doors and portholes. An extraordinary refit is underway while the ship waits for its extra length of hull.
La nave è costruita da
The ship consists and is constructed as an iron, or rather a steel structure, and inside we find the fittings. So when the passengers arrive, they don't see the frame. They just see the carpets and go into their cabins. The objects that we put in the ship are mostly small objects, so they can be brought aboard the ship through any normal door or temporarily removed window, which is easy.
Un finestrino che viene temporaneamente tolto è facile.
Many of the ship's rooms are part of boxes that can be pre-built and pre-loaded to keep construction on the ship at a minimum.
Però pensiamo a delle scatole.
Then when we think about the boxes, such as the bathroom boxes, when the passengers enter, they'll have toilets, baths, and sinks. These are built out of fiberglass and are put together on land.
In vetroresina che sono già costruiti a terra.
The yard inserts oversized items such as bathroom boxes at this stage. But even if other bulky units need to be mounted after the ship has been sealed shut, several different methods can be attempted.
Qui ci sono due possibilità.
Here we have two possibilities. The first possibility, if we're doing an enlargement, is to see how much we can load when the three blocks of the ship are separate. If this is impossible, we'll make a temporary opening in the ship's hull. We'll punch holes in the ship's hull to load the material.
Sullo scafo per far entrare provvisoriamente questo materiale.
The new section, prefabricated with all the utilities already installed, sat on 8 massive trailers ready to be slipped in. Each trailer had 80 wheels that could pivot independently 180 degrees. The SPMTs could also lift the new section to ensure millimetric precision while sliding it in. The skid shoes had moved the bow forward 28 meters, enough for the amazing SPMT trailers to slide the new segment into the new space. Slowly, the massive wheels of the trailers began to move. Then, after a few meters, they rotated, bringing the new section in line with the rest of the ship. Everything had been pre-calculated. Like a gigantic tight curve, an error of judging distance could leave the new section stuck on the corner of the cut ship. Then the ship needed to be pulled back together again. Once again, the Fagioli skid shoes began their Herculean task of moving the ship's bow back to where the stump section had been inserted. Once again, the operation had to be carefully monitored so that the skid shoes moved at the same speed, uniformly shifting the section to connect with the rest of the ship with millimetric precision. Here the hydraulic elevators came into play to bring the edges of the sliced beams and hull to perfectly connect with the new segment.
How do we attach two metal plates together? With the welder, obviously, but it could be an electrode or with a wire, depending on the technique being used. What's the maximum distance between these two plates that I can physically weld together? Only a few millimeters. So imagine cutting a ship that, as we've said earlier, is 28 meters wide with a height of 50 meters from the bottom to the 11th deck with a margin of error of just a few millimeters.
In order for the welder's bead to connect each separate piece of metal, both pieces must be close together. The closer together, the cleaner and the stronger the welder's line will be. Obviously, the hull must be watertight, so the welds must be perfect all the way round the ship. Here in the bustling port city of Palermo, Fincantieri shipyard workers are busy working on the Jumboization of the MSC Opera. Now that the ship is once again a single unit, the furnishings and final utilities have to be completed.
Once the whole of the ship is reconnected, that's to say the three parts of the ship, the bow of the ship, the new section, and the stern. So once the hull and the decks have been put back together, we have to reconnect the plumbing, the electrical wires, and we have to test these systems that were taken apart due to the cut.
The ship has been stretched with surgical precision, and now the workers can get on board and begin turning it into a functioning cruise liner again. The scars of recent surgery are visible, but soon the ship will get a new paint job as well. Most passengers will never know the cruise liner they are on was once a miniature version of itself. As the cruise industry grows and the ships get bigger, vital questions have arisen about the safety of thousands of passengers inhabiting these massive floating hotels far from the seashore.
The second problem with these ships is that they are created, designed to keep you shopping on board, to keep you gambling on board, to keep you entertained and using the inside of the vessel. And so it becomes a labyrinth in an accident. These ships become a trap.
The new hydraulic and electrical systems must be tested while the ship is in the dry dock, before they are tested at sea. If the systems fail at sea, it could be very difficult for the company to return the ship to the dry dock to continue work. The shipbuilder's responsibility is to ensure the structural solidity of the ship, says the Fincantieri yard director, Filippo Otto.
The plant is tested in the dock before the sea tests to ensure that the ship's main plant works.
The structural aspect of enlarging a ship is the most interesting part of the process, because we have to think about how we will be able to enlarge something and make it function as though it were originally built to that length.
In the sea test, we have to verify the maneuverability of the ship, which has changed due to its having been lengthened from its original size. The propulsion and control systems are tested. Speed tests are carried out to see how the ship behaves after the lengthening process. The ship returns to the dock, we complete the last activities, and the ship is delivered.
There is still much work to be done to make the MSC Opera into a viable seagoing vessel, and only many weeks later is the ship ready for service. Fincantieri, meanwhile, has found a fast, low-cost solution to keeping cruise companies competitive by stretching ships and increasing the number of passengers they can carry. Heavy lift and massive naval engineering are probably the least known part of the cruise business, but they are a reliable support partner when it comes to keeping the industry afloat.
noi andiamo ad aggiungerci un pezzo in più e quindi è necessariamente tutti gli
We're
sforzi,
adding another
tutte le
piece,
tensioni
so
che,
all the forces that the sea exerted on the original structure will inevitably change.
Quindi,
So the
la
structural
verifica
verifications
strutturale,
are
è
definitely
stata,
the most
sicuramente
challenging
la
aspect of the
complessità di questo
process.
progetto.
So how did we
Come siamo
commence?
intervenuti?
We tried to
due
keep the
modi
dimensions of the new
differenti per
section
cercando
such
di,
that we can minimize the
dimensionare
changes
il
on the existing
prolungamento
ship.
in modo tale da minimizzare l'impatto sulla nave esistente.
The thickness and amount of steel on the new stump section had to be enough to withstand the stress exerted upon it from the weight of the stern and the bow on either side.
Then we made the structural modifications of the existing ship. We need to ensure that the new modified ship will have the same structural integrity as the ship had before.
Della nave corta.
Before the ships of the Renaissance program can be used in service, they must undergo a series of sea trials to prove their strength and seaworthiness.
Tutto questo,
This whole process, from the time the ship is put in the dry dock until we can send it back out again, lasts 9
9
weeks.
settimane.
The stretched MSC Opera cruise liner will take to the sea as a completely rejuvenated ship, ready to take on the fierce competition. MSC Cruises has only 5% of the world's cruise markets, but now can offer bigger ships at a fraction of the cost of building a new one.
Dopo l'allungamento della nave, la stessa potrà ricevere circa 500 passeggeri in più.
After the enlargement of the ship, she will have an added capacity of about 500 passengers. So basically, the owner of the ship, after 4 enlargement processes, is able to embark as many passengers as if he had a new ship.
Potrebbe ospitare come una nave nuova.
C'è tutta una
It's a procedure that obviously brings results, but the tolerance or margin of error is very small.
parlando sono queste.
This whole jumboization process of the 4 ships in the series cost 200 million euros overall. This includes the cost of engineering for all 4 ships and customized work that needs to be done specifically on each ship. Overall, the project costs 200 million euros.
The cruise ship industry may be controversial, but the technology behind jumboization is truly remarkable. The lifting and moving of tens of thousands of metric tons and cutting metal ships that are 50 meters tall utilizes the most modern of technologies. Recycling ships to make them brand new gives them added capacity to hold hundreds of extra passengers. That saves years of work and hundreds of millions of euros in resources. Although the tourism business will always need new cruise ships, undoubtedly the process of putting these ships under the knife will continue. Almost certainly, there will be more jumboization. A red sun rises over Goose Bay, Newfoundland. The world's biggest aircraft is refueling on the tarmac, on its way from Berlin to Edmonton with a single piece of cargo, a 151-ton heat boiler. The only plane capable of lifting such a heavy object is the Antonov An-225, Mriya. As 6 turbofan jet engines begin to spin, a deafening hum fills the air. Technicians make their last checks on the massive cargo, and pilots prepare for takeoff. The air catches the wings, and the giant takes to the skies. The An-225 is unmatched and unrivaled, a heavyweight in the heavy lift sector. More than a quarter of a century has passed since the maiden flight of the An-225. Since then, the legendary cargo aircraft has broken hundreds of world records and transported some of the largest loads known to man across the globe. Over a quarter of a century in operation, it has moved more than 21,000 tons worth of the widest varieties of cargoes imaginable, from machines and parts to even animals.
Well, no larger planes have been created so far. That's it. I think it's rather expensive to create such a plane, and one needs sufficient experience with large planes, because it's not an easy task.
It is part of the tester's work, but if you are scared, this means this is not your profession.
Our planes have such characteristics and opportunities that they can be marketed throughout the world. The boundaries of Ukraine and even of the former Soviet Union are too narrow for them. Kiev, the great city on the Dnieper River, is the capital of Ukraine, which stretches from the frontiers of Poland and Hungary to Russia and the Black Sea. Until independence in 1991, Ukraine was part first of Russia, then of the Soviet Union. It was here that after World War II, the Soviet government decided to locate one of its prime strategic industries, cargo planes. The Russians were the first to experiment long-distance flight using giant planes, such as this Tupolev An-225, a record-breaking aircraft powered by no less than 7 engines. The Germans developed a powered glider for heavy transport duties during World War II, the Messerschmitt 323 Gigant, or Giant. The world was getting used to mega planes well before the Antonov Design Bureau was founded. The Antonov Design Bureau was built around one of Russia's foremost aircraft designers, Oleg Antonov. The state owned everything, however, so when Oleg Antonov pioneered record-breaking aircraft in the 1960s, he continued to be just an aircraft designer. His team grew and eventually was able to control production of the aircraft in its own factories.
Maria started with Ruslan, the An-124 plane. It was a plane designed by Ole Kostyanovich Antonov, An-124 Ruslan, and the idea that gave rise to our dream also belonged to Antonov.
Everything changed as the world was changing. In Soviet times, we were dealing with aviation tasks, which were financed entirely by the state. The planning was centralized. The government gave us tasks telling us what to do. It provided funds, and this is how the planes were constructed. During the Cold War years, the Antonov Design Bureau came up with solutions to Russia's pressing need to transport troops and weapons long distances at high speed. While the USA was producing the Lockheed C-130 Hercules, Antonov designed and built the An-22, a long-distance transport plane that was the largest of its kind on the market at the time. The world was already full of large aircraft. American millionaire and pilot Howard Hughes paid for the largest flying boat ever built, which still holds the record for the widest wingspan, the Spruce Goose. It flew only once. Boeing converted its war productions into building civilian planes, and the largest airliner of the time, the Boeing 747. The 747 took to the air in 1970, while the US Air Force ordered a number of large planes to transport military equipment halfway around the world, such as the C-5 Galaxy. There seemed no limit to the size of the plane, as long as it had enough power and enough lift in the wings. Over the years, Antonov adopted the jet engine and built faster and larger planes for the Soviet military, and tested new concepts, such as the An-72, with its over-wing engines that increase lift. However, when the US Air Force began deploying its long-distance C-5 Galaxy transports, Antonov and the Soviet Union realized that in case of war, they would have to move just as much military material as far and as fast. Design of the then largest transport aircraft in the world began, the An-124 Ruslan, or, as NATO knew it, the Cossack. It flew for the first time in December 1982. The 1980s were marked by increased rivalry between the USA and Russia in space, too. NASA's Space Shuttle not only carried out experiments in space, but also contributed to the USA's Strategic Defense Initiative, a wall of anti-missile technologies that, it was claimed, took the teeth out of the Soviet threat. In an arms race that eventually broke the back of the Soviet economy, the Russian space shuttle, baptized the Buran, played a key role. Built in 1988, when Ukraine was still a part of the Soviet Union, the An-225 aircraft still operates from the original site of the Antonov factory and headquarters, here outside Kiev. Only 25 years ago, the city was a major industrial center in the Soviet Union. Here, Soviet engineers of the Antonov Design Bureau put together the largest military cargo plane of the time, the An-124 Ruslan, and then were ordered to adapt it to carry the Soviet Union's own space shuttle, the Buran. After the end of World War II, the USA and the Soviet Union vied to break records in space. Although the Russians were the first to successfully send a satellite, then a cosmonaut, into space, the Americans put a man on the moon and advanced space technology through a strategic defense initiative dubbed Star Wars, which included massive funding for NASA's Space Shuttle program. Russia, meanwhile, used the space race to develop its first intercontinental ballistic missiles. The Russian space shuttle flew its first and only spaceflight on the 15th of November 1988. But just as the Americans used a jumbo jet to carry theirs, the Soviets too needed a big plane to carry Buran. They asked Antonov for a solution. The result was this.
In the An-225 plane called Dream, we used Ruslan's wings, and the body, in fact, the larger part of the center body from Ruslan, and the chassis, but we added some changes.
In order to save design time, the Antonov Bureau began using their then largest plane as a base. A twin tail to make space for the Buran, more engines for more power, larger wings for more lift, and a massive cargo hold to be able to carry the space shuttle's ancillary equipment. Objects as large as 11 meters in diameter and 76 meters long can fit inside. But with a payload of 250 metric tons, it could also carry things on its back, which is what it is designed for. The An-124 Ruslan morphed into something quite different, but clearly related. The Mriya, or Dream.
The changes were quite significant. They included an additional center part of the wing and the additional engines, because there were 4 there and 6 here, and the rear loading hatch was closed in Mriya. In other words, these were in fact the main parameters.
Among the unique characteristics of Soviet-era aircraft are their robustness. Sturdy frames and tough undercarriage were a fundamental part of Soviet design strategy, to enable aircraft to survive a potential nuclear war and deploy to irregular or semi-prepared airfields.
Like all Antonov's planes, this one was designed to land not only on paved, but also on unpaved airfields. This explains the number of chassis. And respectively, the frame is large. This all has to be buffered during the impact stress during landing. It has to be distributed, and the number of chassis was designed respectively.
However, not only had the aircraft to be able to survive tough landings, but the airfields had to survive the giant's weight plunging onto them too. The plane's payload is a whopping 250 metric tons. The Antonov 225 has an increased capacity landing gear system with 32 wheels, some of which are steerable. It was designed so the aircraft could turn on small runways. On each side, there are 7 pairs of wheels, plus 2 front landing gears with 2 wheels each, explains Grigorenko Maxim, who is in charge of maintenance on the Mriya.
There are 7 rows of the main chassis. They are special because, despite of the big size of this plane, the last 4 rows are rotary racks. Despite its dimensions, the plane can turn round in a small place with minimum radius. When the plane is towed, these wheels can turn as well.
In the tiny cockpit, conventional instruments move the control surfaces hydraulically, and the throttles for the 6 massive turbofan engines are still manual. The cockpit opens onto a corridor where the crew and technicians can rest during a long mission. Dmitry Antonov has worked for 22 years at Antonov, since retiring as a military pilot and instructor. He has flown nearly every Antonov-designed plane, including this one, the most massive of them all.
This aircraft, Antonov 225, also Antonov An-225, Antonov 7274, Antonov 148, 158, and another one aircraft.
It is a unique experience to be at the cockpit controls of this one-of-a-kind plane.
I'm driving the biggest aircraft in the world. Just only this one. But for normal control, it's not easy, but it's not so hard. It's you have all control, and you have big team flying with you. We are working and have a good team spirit, and everybody trying to help and working for captain for to make a safe flight.
His crew of pilots, engineers, mechanics and technicians must all know the AN-225 in great detail. They must be autonomous so that wherever they land, they can troubleshoot any problems on their own.
Nobody knows this aircraft. We have to, after landing, we have to make loading, offloading, fueling, and maybe if we have some problem with equipment, to make small maintenance or repair something. That's why totally, usually we are flying 18-20 person on this aircraft. We have 2 cabin here, just it's pilot cabin, and have technician's cabin in rear side. And enough space to feel like home here.
He has come to know every corner of the cavernous aircraft, whose vast spaces are remarkable.
It's totally, we have 6 beds. It's good for who make the decision to prepare for long flight and to sleep here, to take a dinner. Also, we have small kitchen here to prepare coffee, tea, or heat catering. And here we have big space for just, it's simply space for, we can walk here, and also we are keeping here some spare parts for our navigation equipment, for all other system. You can see its equipment, navigation equipment, fire protection system, and also it's the finish. We can proceed from here to top of aircraft.
Actually placing a load inside such a massive aircraft was a huge challenge, so designers had an internal crane built inside the cargo hold.
It's almost 44 meters long, it's 6 meters wide, and more than 4 meters high. Inside you can see everything what needs to load aircraft. It's loading equipment to crane to take any kind of cargo. We have equipment to fix aircraft, fix this cargo inside compartment, and also some spare parts, spare wheel, and our, for example, here it's a tow bar because it's need sometimes to towing aircraft on ground. Here it's door through this door we can proceed to technicians compartment. It's not connecting with pilot cabin, but it's the same quite enough space to stay our technicians during the flight.
Remarkably, there is a lot of space that goes unused. The loadmasters are also catered for, with ample space for dining, sleeping, and passing the hours in flight.
It's small kitchen here to prepare, and it's a place where the technician sitting during takeoff and landing. And the backside you see 11 beds. It's good for rest.
A kneeling undercarriage and a folding nose loading ramp are the heavy lift hallmarks of the An-225. It literally loads and unloads oversized cargo through its nose and kneels using retractable nose gear, allowing deliveries to drive directly into the cargo bay. Several small suburban houses or 80 mid-sized cars can fit inside the cargo bay. There were other major ways the aircraft differed from its smaller brother, and from every other aircraft around the world. It is the one and only such aircraft in the world, dwarfing the Boeing 747 and outlifting the C-5 Galaxy transporter.
And with regard to the forebody, almost nothing was changed if we compare An-124 to An-225. And, of course, in view of the larger capacity with regard to the length of the center body and the wings, the plane's carrying capacity was increased to 250 tons maximum. That's all.
The wingspan of the aircraft was extended from 73 to 88 meters, and the wing profile was modified too, to give it extra lift at the junction with the fuselage and greater width to house even more fuel, an incredible 300,000 kilos worth. The extra fuel was needed to power the 6 Ivchenko Progress D-18T engines, built in the Soviet Union, now Russia. Each of these engines provides 51,600 pounds of thrust, enough to push the aircraft up to a takeoff speed of over 850 kilometers per hour. The wing profile and thrust gives enough power to get the 280-ton aircraft and all its fuel and cargo, a stunning total of up to 640 tons, into the air, to a cruising speed of 800 kilometers per hour. On the 1st of December 1988, the Antonov Design Bureau finally presented its plane. It had not flown yet, and many wondered if it ever would. The Mriya lifted off the snowbound runway and graced the skies over Kiev with a 74-minute maiden flight. That day, it set 106 world records for aviation.
These were quite difficult times. These were the times before the collapse of the Council for Mutual Economic Assistance, CEB, and the USSR collapse. Yet although our firm was working like we are working now, everything we were doing was done on the basis of great enthusiasm.
Upon seeing the An-225, the first pilot was reported as doubting whether the plane could actually manage to lift off the ground. Alexander Galunenko is a test pilot, one of the people tasked with trying out new planes. He flew the An-225 with the Buran piggyback all the way to Paris.
That's why back in 1989, when the program wasn't closed, we flew with Mriya in May 1989 to Baikonur, where we put Buran on it. And we conducted a series of tests with Buran. And then we flew with this Buran back here to Gostomel. And then we flew to Paris, Le Bourget. And we showed this tandem, Mriya-Buran.
And before the Soviet Union collapsed, this system began to fail. The state financing was constantly decreasing, and we had to think how to go on. We had to find ways to earn money in order to build new planes and to continue our aviation work. And this is when this idea was conceived, for us to start to provide air transportation services. The An-225 didn't just dazzle Paris, but was showcased in many countries during the tensions of the Soviet era. Before that, we exhibited our planes at various air shows in the world. In Paris, Le Bourget held every 2 years. Farnborough, we were in Singapore, we flew to the US. All that during the Soviet Union times, to show our planes. The decline of the Soviet Union was marked by the worst nuclear disaster the world had ever seen, the explosion of the second reactor in Chernobyl, close to the Ukrainian capital of Kiev. The radioactive fallout took many victims, and as the scope of the environmental catastrophe became clear, the population of the surrounding area was displaced. This was the An-225's first humanitarian mission, just before the Soviet Union collapsed.
Well, let's say in 1990 to 91, I had to transport cargoes. At that time, Ukrainian diaspora in America collected some medical equipment for the children who suffered the results of the Chernobyl disaster, which was needed. It was important for them to make it visible, and they asked even the president, if I'm not mistaken, to send them not some Ruslan, but Mriya specifically. So I brought several such shipments from Newark and from Philadelphia.
The collapse of the Soviet Union was an unexpected event, and many of the planes that were in the design pipeline would never be realized. The Antonov Design Bureau, however, would manage to keep this giant of the skies alive. The Soviet Union had plans to build several such planes. And there is a second plane. Yet it is difficult to say to which extent it is ready, maybe about 40%. Well, it was as it was. There were no funds available to complete construction of the second plane, and it remained unfinished.
And the plan was to create several such Mriyas. Then the Soviet Union collapsed, funding ceased, and we were not even able to complete the final flying tests in order to receive the certificate.
The Antonov Airlines factory near Kiev continued, but the An-225 was sadly parked for storage. It would be mothballed for 7 years before the Antonov Airlift Company managed to get it repaired and certified for commercial use.
And only 7 years later, funds were found, internal financial resources that enabled us to modernize Maria for the commercial needs and complete these approximately 20 trial flights in order to obtain the certificate. And then it could transport cargoes flying all over the world.
That is why the experience of Antonov, both with regard to the use and maintenance, is great, because it is about not only aerodynamics, but also the capacity, resource, reliability of the supporting system. And the Maria has all of it.
In the year 2000, the plane went through a series of upgrades and repairs, and then again made its first public debut in May 2001 at the ceremony of the opening of the new Borispol-Kiev airport. In June, Europe got its first look at the sleeping giant that had been modernized to take to the skies once again. It was displayed at the Le Bourget Air Show in France. September the 11th, 2001 would make aviation history in more than one way. In order to demonstrate its potential to the world, on the 11th of September 2001, we performed a record cargo lifting of 253 tons for 10,500 meters of height. Yet, since this event took place on the 11th of September 2001, another event that happened at that time overshadowed this record. The terrorist attacks on the World Trade Center in New York would forever overshadow the 124 world records broken by the An-225 that day. It flew with 4 Ukrainian tanks, a total weight of 253 tons. With that heavy cargo, it reached a top speed of 763 kilometers per hour, but very few gave it much attention. The September the 11th attacks led to 2 massive wars in Iraq and Afghanistan, in which Antonov Airlines and An-225 would fly missions for the US Army engineers and special forces into some of the most dangerous territory in the world. In one particularly dangerous mission, the An-225 flew gas turbines into the heart of the fighting in Iraq to the Baiji power plant. Our planes are also often used for transportation of military equipment. All these operations are carried out in accordance with intergovernmental agreements, when diplomatic permits are obtained as required. So we transport military equipment from one continent to another as well. Our planes were very often used during operations in Afghanistan, Iraq, and before that, in the Persian Gulf, during the Desert Storm, if you remember the 1991-92 war, the Desert Storm operation. Our planes were used to carry bulldozers and other equipment to put out burning oil wells in that war. Back in Kiev, Sergei Slusharenko manages the Antonov heavy lift operations and cargo carrier requests coming in from all over the world.
I am an operational duty attendant. We support charter flights for our Ruslans, our experimental planes. All planes that fly in NTK Antonov receive support in accordance with the orders, handlings. Kerosene is supplied in all airports from which we fly. This is our responsibility.
In spring 2015, Antonov Airlines was contracted to transport a boiler from Berlin to Edmonton, Canada, for use in a new water waste plant. The mission required careful planning. The unit had to be moved all in one piece. no other means of transport was efficient enough for the job.
Because these are unique planes, and cargoes are sometimes very difficult. Up to the unique cargoes weighing 186 tons that are transported with Maria. For them, special time is required to prepare loading equipment. For instance, some heavy generators or welded frames and so on. This is developed by our load planning, which is a special office that looks, calculates, sometimes examines these items and says what they need.
The cargo weighed 151 tons, too heavy for any other transport plane, and without the Mria, could only have been transported by sea, a lengthy and risky transatlantic voyage.
We receive commitment advice from the businesses, the transportation contract, and we prepare the schedule, select the most suitable option that ensures the safest and cheapest transformation for the customer. Then we reconcile the price and begin to plan the tasks. We submit requests to the Ministry of Foreign Affairs for military transportation, and requests are also submitted for civil lines. We form the briefing and support the flight performance.
The An-225 is often in demand because of its advantages when it comes to speed and performance. In proportion, it is far more cost-effective than any means of transport, although it is a massive fuel guzzler that leaves a huge carbon footprint.
Не зависит время выполнения рейса от типа самолета. То есть
The time of flight performance does not depend on the type of plane. Maria is a unique plane, and it began to be used more often recently because the world market is somewhat inert, and it needs time to learn that some cargoes were transported in this or in that region. This is why recently, when the French began to transport cargoes from Africa from various difficult airports, they saw that Maria was highly efficient, because, for instance, Rusland can transport only 60 tons to the nearest point, whereas Maria can transport twice as much, 110.
Только 60 тонн груза до ближайшей точки, где Мрия у нас фактически может в два раза больше вывести груза, 110.
This plane, as well as Mria, was designed for transportation of very large cargoes, and they are big planes. Big planes create big aerodynamic resistance, and very powerful engines are necessary to overcome it. Powerful engines require a lot of fuel. That is why the capacity of the fuel tanks in the An-124 is 273 tons. 273 tons make it possible to fly for many hours, more than 24. And in Mria, the fuel tanks can hold more than twice the An-124. After nearly being retired, the second career of the indefatigable An-225 had only just begun. The An-225 flight from Leipzig in Germany, carrying a massive 151-ton boiler to Edmonton in Canada via Goose Bay, is underway. The crew can relax in the lounge built in the aircraft tail, while the pilots take turns at the controls, occasionally able to sleep. The flight is long, but broken up with refueling stops at Reykjavik and Goose Bay, where the glorious dawn allows the Antonov Dream to live up to its name. The mega airlifter takes off on the last leg of the flight, with wings bending under the weight of the 300 tons of fuel that are needed to get it to its destination. As the plane flies empty only when it has to, for instance, after it was unloaded and has to fly to pick up a new load, the fuel tanks are almost never full. The plane is loaded, and it can take only as much fuel as is necessary to fly to the next airdrome. Despite its enormous size, the Mriya is more cost-effective than most giants of the air. Mriya needs 20 tons of fuel during the first hour of its flight, and then 18, 17, and less. The weight of the plane decreases as the fuel is burned, and the fuel consumption decreases. So, big planes need a lot of fuel. The Antonov Airlift Company has been called upon to transport humanitarian cargoes too, such as to the 2010 Haiti earthquake site and to Japan the following year. The Mriya is perfect for the job, as it is a single plane with one cargo and can get the job done in just a few days. In 2009, the US Federal Emergency Management Agency contracted the An-225 to fly 10 massive generators into American Samoa after a tsunami damaged a power plant.
On board the Antonov are 10 500-kilowatt generators. We're about to begin the offload process. They'll be brought over to our generator staging area about 2 miles away. In the next several days, they will be deployed from the generator staging area out onto the island. The reason why they're here is because there's not enough generation capability on island with the loss of one of the power plants. These generators, plus the generators that we already have on island, are going to help stabilize the electrical grid throughout the island. The reason why this plane was used to transport the cargo is we have all 10 generators on one aircraft. This is the only aircraft capable of moving this load at once.
Today, Antonov Airlines flies a mix of humanitarian, military and commercial missions.
Last time we transported from England, East Midland if I'm not mistaken, pressure equipment for production of Jaguar car bodies. They relocated their production facilities to Detroit, USA. We flew to Toronto where we unloaded, and then it was near and they transported their equipment further on themselves. There were no special technical things. The cargo was heavy, almost 180 tons. 170 and something was the weight of this pressure equipment. For Mriya, such cargoes are normal and customary.
The Antonov Company, based in Kiev, Ukraine, constructs and designs aircraft for a niche market, transporting the heaviest objects in the world that need to be moved from one place to another. As well as having the largest operating plane in the world, it has a fleet of heavy-lift aircraft, many of which have the capability of landing on unpaved and uneven airstrips in the most far-flung destinations. The An-178 is one of these planes, and a new prototype has just been built.
And An-178 is the plane that can carry approximately 15 to 18 tons of cargo, which is very important. It can carry various types of cargoes, and it has a sufficiently big cabin. It can also transport marine containers.
Marine containers.
Rain pelts the tarmac as the new An-178 prepares for its maiden flight from Kiev on a stormy day in May 2015. It is slowly towed into place by Antonov technicians, eager to see their new design take flight. As the pilots prepare for takeoff, spectators huddle along the runway, braving the bad weather to watch the new prototype lift off.
This
plane has a rather high speed. It can be used in unpaved airfields, and today this niche is vacant. Which niche? It is for the planes with the carrying capacity between 10 and 11 tons and 20 tons, exactly 15 to 18.
After landing, the successful first flight is celebrated by decorated military officers, government dignitaries, and representatives from the commercial aviation sector. It is a rare showing of public fanfare in this country ripped apart by war. a moment for Ukraine to remind the world of one of its standout industries, aircraft engineering. The recently unveiled prototype AN-178 may be part of the next generation of Antonov planes, but that doesn't mean that the life of the AN-225 is over. To fully understand why Antonov is such a player in heavy-lift aircraft, it is important to look at the market. While there are similar planes with massive heavy-lift capabilities built by Boeing, like the C-17 Globemaster III and Lockheed's C-130, these planes are for military, not commercial use, making Antonov one of the only private sector choices for the transportation of massive cargo. There is no other plane that looks quite like it. With its nose able to open up for a loading ramp and its kneeling undercarriage, the AN-225 Mriya is capable of lifting off the ground with a load of 640 metric tons and fitting 4 small suburban houses in its cargo bay. This monster of the skies has carried the biggest man-made objects in the world and retains its title as the largest airplane in use, even after nearly 3 decades.
Thank God, the plane is 25 years old and we have only removable problems. I mean, it hasn't required any global improvements so far, and there was no need for them in individual systems. Everything that is worn or broken in the process of use is replaced. In other words, this is a normal operation process. Of course, planes are getting old, and they need more attention, that's all.
Until the aviation industry can develop an aircraft with the same heavy lift capacities, the Mriya will remain one of a kind.
Mriya remains the largest plane or transport plane, the largest plane in general in the world. I think no one is building a larger plane so far.
With regular checkups and mechanical repairs, the life expectancy of the AN-225 could be extended to 50 years in full operation, giving this mighty, record-breaking aviation giant another quarter of a century in the skies.
The picturesque lagoon on which the iconic city of Venice was built has always been this former maritime power's lifeline, offering crucial protection from the mainland and easy access to the sea. But the very waters that were its historical ally also became Venice's greatest enemy, with recurrent flooding across vast tracts of the city. In a marvel of modern naval engineering and heavy lift technology, the Italian government and a consortium of private enterprises is building a 7.3 billion euro water barrier system to safeguard this romantic city of water for future generations. The streets of Venice flood, a phenomenon known here as acqua alta, when strong southeasterly winds and a high astronomical tide cause an unusual inflow of water into the Venetian lagoon. Exceptional tides, measured here at Punta della Dogana, have occurred more frequently over the last century and risk catastrophically damaging the whole lagoon and the city itself. Venetians have long been accustomed to coping with the inconvenience of acqua alta. In 2003, the Italian government began building an ambitious feat of engineering to stop the devastating high tides and save the city. A massive surge barrier with 78 floating gates to close off the lagoon when flooding occurs.
Let's say it's a problem of preservation of the city's monumental heritage.
Thanks to exchanges with the environmentalists and to the improvement of the technologies, we have created the most important and probably the greatest environmental initiative in the world.
You can't just finish part of it and then see if it works. We're going to have to wait until it's completely finished.
Venice is sinking due to a twofold mix of natural and man-made problems. Climate change has caused the Adriatic to rise, but Venice also suffers from shifting plate tectonics, meaning the ground underneath the city is sinking. This problem is made worse by the reckless pumping of groundwater for use in petrochemical plants nearby.
We estimate that the sea level has risen by 12 to 13 centimeters, so the sum of rising sea levels and the sinking soil totals about 25 centimeters. So the city of Venice over the course of the last century has sunk approximately 25 centimeters with respect to the average sea level.
In 1966, flood levels in the city reached a record 1.94 meters, roughly 6 feet, causing immense damage to the city's building and giving birth to the Save Venice movement. Recognizing the need for a permanent solution, city authorities hatched a plan for the separation of the lagoon from the sea at high tide. The project was baptized Mose, an acronym that stands for Modulo Elettromeccanico Sperimentale, or Experimental Electromechanic Module.
In 1966, Venice flooded dramatically. It was the worst flood ever recorded and lasted longer than ever before. And so the Italian government decided that Venice had become a national problem and that the city had to be saved from the high waters. So, from that moment onwards, a series of ideas emerged, and then projects were launched that are now being concluded after many years, to create a system that stops the rising waters outside the Venetian lagoon, protecting the city from flooding.
The Mose project was all the more ambitious because of the geography of Venice. The Venetian lagoon was formed about 6,000 years ago as the coastal plain shifted following the last ice age. Today, it stretches 550 square kilometers from the river Sila in the north to the Brenta in the south. The city of Venice and the smaller islands around it altogether only account for 8% of the lagoon area, while 12% is permanently covered by open water and canals, and 80% is mudflats, tidal shallows, and salt marshes. In fact, it is one of the Mediterranean basin's largest wetlands. The lagoon is connected to the Adriatic Sea by 3 large openings in the natural sand barrier. They are the Lido, the Malamocco, and the Chioggia inlets, where the tide enters and exits twice a day.
The seawater enters the inlets and spreads gradually into the lagoon. From the inlets, it spreads along the canals. It goes faster along the canals, but also around the sandbanks and the deeper areas. And when the tide recedes, the sea level goes down, and the waters flow out of the lagoon inlets once again.
During and after the fall of the Western Roman Empire, the inhabitants of the Venetian coastal plain fled the invading barbarians and came to live on the dozens of islands surrounded by the shallow lagoon for the protection it afforded. Over the centuries, the lagoon became a natural base for the great Venetian trading empire. The Venetians built their city by driving giant oak poles up to 4 meters into the muddy flats, effectively petrifying and preserving them. they put planks on top of these pillars and marble foundations on top of the planks. Over time, the Brenta and Sila rivers deposited in the lagoon, blocking the navigation channels, and Venetians found it necessary to redirect the rivers so they flow directly into the sea instead of into the lagoon. Large-scale naval engineering projects, including hydraulic pumping and the redirection of rivers, have been underway for centuries and have altered the natural evolution of the lagoon, creating canals and a number of artificial islands. Battling high and low water has been a part of Venetian life for hundreds of years. The Mose project, however, is the most complex and massive naval engineering project in the city's history. The idea that Venice could be protected from the sea by a series of barriers began to gain traction in the 1970s. Other surge barriers in London, St. Petersburg, Russia, and Rotterdam in the Netherlands showed that the concept could work, but actually building it in Italy proved far more complicated than expected. Like all costly big engineering projects in Italy, it encountered strong opposition from environmentalists, became vulnerable to corruption, and fell into a web of contradictory local and national powers.
When the project was first designed 30 years ago, it was essentially an engineering project, and so we approached the problem in a very, let's say, hard way. Today, there are two sides to the project: the engineering side, but also the environmental side.
Construction of the Venetian Mose began in 2003, and the surge barrier is expected to be complete and fully functional in 2018. The Mose project was tailor-made to protect Venice, with 4 major barriers installed at the 3 main lagoon inlets that connect the lagoon to the Adriatic Sea. The Venice surge barrier consists of 78 floating steel floodgates arranged into 4 rows of various sizes, widths, and lengths. They are all independently operated and housed in tanks anchored to the sea floor. Each gate lies horizontally on the seabed when not in use, but when the tides over 110 centimeters are predicted, the barriers rise up on their hinges. After the threat passes, the air is released and the barriers can sink down again.
La spinta di galleggiamento fa moltissimo. Proviamo a pensare che siano...
The flotation forces do most of the work. Think of them as buoys, which are submerged except for the last part. So they are controlled with pressurized air inside the barrier and absorb the force of the wave. But the air inside the barrier compensates for it.
Subiscono la forza dell'onda, cioè la spinta dell'onda, ma l'aria all'interno della paratoia la contrasta.
Over time, the Mose project morphed from being a purely engineering project to encompass also the recovery of lagoon wetlands that had been eroded over the centuries, and the recovery and restoration of Venice's ancient arsenal, which became the control center of the whole project, now run by the construction consortium Venezia Nuova, or New Venice.
The work we have done over the last few years has been varied: land recovery, reinforcement of the coastline, decontamination, protection of polluted areas. All this to regenerate and improve the lagoon and the quality of its water.
Over the course of a 15-year infrastructure project, the work has often been bogged down by political quagmires and kickback scandals. One of the most vocal opponents of the Mose project is Luigi Lazzaro of Lega Ambiente.
Questo modello, diciamo questo Italian style.
This model, this Italian style of managing the bids and sub-bids in-house that determine who gets the project and then inflating the costs year after year is a direct result of the new Public Works Law. Now we are up to 7 billion euros, with the Mose maybe being completed in 2016. Then we'll see how much money it will cost in the future.
E poi vedremo quanti saranno nella realtà nel futuro.
It is one of the most complex and costly public works projects in Italian history.
Il budget della costruzione sono circa 5 miliardi.
The budget of the construction is approximately 5.5 billion euros, spent over 10 to 15 years for construction. In general terms, we think maintenance will be 30 to 40 million euros a year.
Noi pensiamo che la cosa sia fra i 30 e i 40 milioni di euro all'anno.
But it is the Mose surge barrier that is at the heart of this massive new effort to protect Venice. The heavy lift company Fagioli was called in to move some of the key elements of this massive engineering operation, together with construction company Mantovani, the Venice Water Authority, and the privately owned consortium Venezia Nuova. After centuries of devastating floods, a plan to save Venice from the rising sea and the sinking city finally surfaced. Each of the 12,000-ton concrete housings had to be moved from the building site to the lagoon entrance. While the Lido and Chioggia barrier housings were built close to their final destination site, the caissons for the Malamocco lagoon entrance were built far from where they were to be laid. Moving the concrete barrier housings from the building site to their designated place on the sea floor, and then installing the mobile barriers, was an epic lifting job. Fagioli first had to deliver a lifting structure that would allow the caissons built for the Malamocco entrance to be lowered into the water, as the site could not be flooded like the others. In order to sink the caissons here, the consortium built the largest synchro lift in the world, made up of 26 beams, each 57 meters long, activated by hydraulic winches that could lower the caissons underwater so that they could, in turn, be lifted and transported.
The synchrolift is a synchronized elevator that allows us to lower things in water. Structures that aren't only very large in size, but above all, extremely heavy. And with this lift, we can carry caissons that weigh up to 22,000 metric tons.
The massive crossbeams of the synchrolift were transported onto a specially designed barge using self-propelled modular transporters. They are equipped with dozens of wheels that can rotate individually through 90 degrees in order to move massive weights in any direction. It took 3 to carry each of the beams to the barge, where they were loaded and taken to the construction site, where they were laid side by side and attached to the massive hydraulic jacks that provided the lifting and lowering power. Fagioli was also contracted to move some of the concrete caissons from the Lido Tre Porti building site. In order to move the massive concrete caissons, Fagioli engineers designed a unique tool for the job. They designed a catamaran structure with 2 river barges bound together with crossbeams equipped with strand jacks. A special wedge-shaped connection provided the catamaran with the necessary rigidity to perform the massive lift. The unit was designed and built at the Fagioli yards at Cremona on the Po River, under the direction of Loris Giovannini.
Il porto di Cremona è stato un polo molto importante per il Mose.
The port of Cremona has been a very important location for the Mose project in that it had the shipyard where the catamaran was pre-assembled. The catamaran was constructed out of 2 existing river barges that were taken out of the water in the port of Cremona, put in the dry dock in order to modify them and utilize them as the catamaran. In the port of Cremona, the 2 crosshead beams were constructed that would constitute the catamaran. Once assembled in the dry dock, the whole catamaran was disassembled and piece by piece, barges and beams were transported to the Lido Tre Porti.
E pezzo dopo pezzo, mi riferisco a chiatte e travi, sono state poi portate al Lido Tre Porti.
For this heavy lift job, the catamaran needed a total of 20 strand jacks, able to lift from 45 to 294 tons. They do the heavy lifting of the concrete caissons.
In particolare sono stati utilizzati 4 strand jacks per la
4 strand jacks were used to sink the caissons. There were 4 vertical strand jacks that let us sink the caissons to their correct depth.
Dopodiché sono stati utilizzati 12 strand jacks.
Then we used the 12 L50 strand jacks with a capacity of 50 tons for the secondary mooring. That connected the caissons to the catamaran. Then, another 4 L300 strand jacks with a 300-ton capacity were used for the primary mooring system, which allowed the catamaran to move the caisson to its final resting place.
Fino alla posizione finale di installazione.
The single most employed instrument in all the transportation of the 12,000-ton caissons of this mega project was the strand jack, which uses an electrically activated hydraulic pulley to raise massive weights spread evenly among the dozens of cables lifting the load. Strand jacks were famously used to pull the 100,000 tons of the Costa Concordia over 12 hours from a 60-degree list to the vertical in the 2013 parbuckling operation. In July of 2012, one of the massive concrete caissons on which the individual floating barriers were to be attached was ready to be moved. Once ready, the basin was flooded and the caisson started floating, but then had to be partially sunk by pumping the air out of the tunnels built inside them. 2 tugboats dragged the caissons one at a time out of the basin to a sheltered area. Though the caissons were secure, every safety precaution was taken to make sure nothing went wrong. Special propylene axle lines were fixed to the special transport trailers parked along either side of the shoreline. They crawled along with the slowly moving caissons. The heaviest lift of Italian history had begun. Once the caissons had arrived at the sheltered bay, the tugboats were disconnected and the launching operation began. The 2 tugboats were hooked up to the catamaran. The launching operations involved connecting the lifting points of the caissons to the catamaran for the so-called secondary mooring system.
Il cassone è stato consegnato a Fagioli.
The caisson was delivered to Fagioli already floating. It had a dry weight of 12,500 tons. It was connected to the catamaran Alpha inside the basin and then connected to the mooring system.
Mediante delle cime di ormeggio. Arrivato esattamente sopra la zona di installazione.
Once we reached the exact point of installation, the caisson was ballasted until it became very heavy. Then it was dropped down to the seafloor by the hydraulic pulleys, or strand jacks.
Dal pelo libero fino al fondale marino.
Once the structure had been connected, the catamaran was pushed by tugboats until it arrived over the underwater primary mooring system. Long wires called trench access lines showed the pathway or line to follow in order to get the concrete structure over the trench carved in the sea floor and reach the precise sinking point. Once in position, the caissons were ballasted and sunk using strand jacks positioned onto the catamaran. Water cushions previously positioned into the seabed were filled, gently taking the load of the caissons before they reached the bottom of the trench. The bags were then deflated, allowing the placement of the caissons in their final position. Engineers used precise 3D computer models to place the caissons with millimetric precision and slide one against the other to form a single watertight line. Even the smallest error could mean disaster for the Mose project. However, this was just the first stage in the massive move. Once the caissons were lowered, the floating barriers had to be attached. This was a massive feat of engineering. In 2003, the Italian government began investing billions into a project called Mose, a massive barrier to control the tides flowing in and out of Venice from the Adriatic Sea. Here at Lido Tre Porti, the Mose construction site rises out of the sea, a massive grey wall of concrete. But what is underwater and how does it work? 20 meters beneath the sea are a series of massive concrete caissons.
Every barrier has its 7 housing caissons and 21 gates and 2 service tunnels, one on each flank.
Workers who build and maintain these undersea tunnels take a lift to the bottom of the shaft. It is an imposing labyrinth of metal, concrete, and cable. There are 2 tunnels, one for transport and another a lateral service tunnel in which repairs can be carried out in a hurry if there is a leak. Watertight rooms along the side of the tunnel host the attachment mechanisms connected through the watertight female housings to the male part of the hinges on the outside of the caisson, round which the barriers move when compressed air is pumped into them. Each of the hinge rooms is flanked by a service chamber that allows a diver to enter the hinge room to carry out any emergency repairs if it is flooded. The watertight doors need to be checked regularly. They must be kept closed at all times. Each caisson was lowered and pulled against the next with millimetric precision, so as to make the whole length of the undersea tunnel completely watertight. The next phase in building the Mose is positioning the mobile barriers. Once again, the heavy lift company Fagioli was called into play. In this hangar in the Maghera port shipyard south of Venice, the massive yellow floodgate is finally ready to be moved. If you think moving a piano is hard, imagine this 210-ton steel box. The whole process of moving the barrier out to sea would take 3 full days. Fagioli uses a special heavy lift transport vehicle to slowly roll it out onto the awaiting barge. It is a tedious and dangerous process to move such a beast. Finally, at dusk, the barge transported it at a snail's pace, passing by San Marco after nightfall. A brief glimpse of the very city it is destined to protect. In order to do the final, most delicate phase of installation at daylight, the crew docks for the night. Dawn rises over Venice. The city of water slowly wakes, doing its daily business by boat. The barge with the great yellow gate heads out to sea to its final resting place.
After we lowered the 7 caissons, Fagioli was also involved in the laying and installation of the floodgates. To do this, we utilized a scaffolding structure that was constructed of trellis towers and beams connected to the towers.
The tailor-made system included a 4-tower structure with 2 crosshead beams on top, each equipped with 4 strand jacks, necessary to lower this gigantic 210-ton barrier into the water. The support structure was called the fishing beam, as it would be used to hook the mobile barrier with 14 by 14 axle lines. The axle lines had to be perfectly constructed. When the structures were ready, a large barge equipped with 4 sets of gantries was maneuvered into position, and the tower legs, connected to a bottom frame, were joined to the 4 tower sections. This was a delicate stage. Every connection had to be precise to the millimeter. Workers monitored every parameter using radar, adjusting the cables and hydraulic pressure as needed.
La chiatta con a bordo la paratoia è stata trasportata fino a Bocca Lido Tre Porti.
The barge with the floodgates on board was transported to the Lido Tre Porti inlet, and there it was floated under the 4 strand jacks mounted on the launching legs. The weight of the lifted floodgate is almost 250 metric tons. The strand jacks allowed the floodgates to be lifted from the barge and lowered onto the caisson with millimetric precision.
Con una tolleranza anche qui millimetrica.
Once the caissons had been laid, the barges loaded with the barrier were moved directly under the launching structure, so the fishing beam could hook the barrier. After this, the area was cleared from the barge, and the barrier was lowered into the water using the strand jacks. Then the mobile barrier was freed from the support structure and fixed to the caisson. Any misstep could send the 200-ton gate to the bottom of the sea. Finally, the barge came back to load the launching gantry system and repeat the whole operation with the other 3 barriers. This will be done 78 times. This is the old arsenal, ground zero of the fight to save Venice from sinking. Once the former shipyard of the Republic of Venice, today it is reclaiming its place as the power center of the city. Here, in the main command and control station of the Mose project, engineer Hermes Redi is in charge of managing the Mose's reaction to the combination of high tides and adverse winds.
As we've said earlier, the floods are caused by a combination of several events. One is the normal tide. The other is the southeasterly wind, which pushes the water towards the upper Adriatic, and so against the lagoon. And lastly, there is a standing wave which contributes to rising waters.
He works hand in hand with the engineers and technicians of the City Tide Center to analyze the meteorological and tidal data coming into the control room. It is here where the crucial decision is made to close or open the 78 gates that make up the barrier.
The parameters of the screen that you see on the upper left are the monitors that give us the actual position of every barrier, its position and its state, should we need to activate them. The central part is dedicated to the weather forecast. All the other screens give us information about the lagoon surroundings, the Mediterranean, and the Adriatic Sea, all the data near our area that allows us to have a clear picture of the meteorological situation.
There are many parameters that determine exactly how many gates are opened, where, and in what order.
We can see normal tides, high tides, very high tides, and we can react to each individual situation differently.
Today, science and technology allow for the forecasting of when flooding will happen, but there is a deadline.
Siamo in grado di prevedere con giorni di anticipo la possibilità dell'arrivo dell'acqua alta e anche
we are able to predict several days in advance when a flood tide will occur and to forecast the tides quite accurately. But obviously, as we get closer to the day of the flood tide, our ability to forecast what will happen improves. So therefore, the real moment to decide whether or not to close the lagoon with the flood barriers happens about 3 hours before the event, because at that time, we can determine with total certainty what is about to happen.
Prima dell'avvenimento, perché in quel momento siamo in grado di prevedere con una precisione assoluta quello che capiterà.
Multiple meteorological factors must be calculated. The decision was made to use the Mose only when the tide is at 110 centimeters above average or higher. Under this scenario, flooding will still occur. Using various simulations, Venice authorities are able to determine with precision exactly what impact floodwaters of different levels will have on their city.
Venice is underwater in a very small number of places when the sea rises 80 centimeters above the average sea level. But the areas subject to this flooding, as you can see, are the most famous areas of the city. St. Mark's Square is the first to flood, and Rialto immediately afterwards.
But when the water level rises to 100 centimeters, 1 meter above average, St. Mark's Square is completely underwater, and some smaller streets begin to have some problems. At 110 centimeters, the famous rubber boots become a necessity to get around the city.
At 130 centimeters, the city isn't completely flooded, but it is certainly completely impacted, which means that not only the ground floors and not only the shops are flooded, but the storerooms can't be used, and people can't get around freely.
At 140 centimeters, rubber boots are no longer any help, and the city becomes extremely difficult to navigate. But it is the epic flood levels like that of 1966 that are the biggest worry.
Basically, in that situation, Venice is completely underwater.
Once the Mose has been activated, the 78 single barriers emerge from the seabed in groups of 4, effectively creating a wall between the lagoon and the sea. A control system keeps the inclination of the gates when closed at approximately 45 degrees, constantly adjusting the water inside. When it is time to open the barrier, the gates are filled with water, a process called ballasting. They slowly come to rest flush with the seabed, invisible from above. Massive hinges that weigh 42 tons keep the gates attached to their bases. There are small gaps, just a few centimeters wide, which allow a little water through, but more importantly, allow the gates to move and rotate on their hinges as necessary. In October of 2013, the first test was conducted on the Mose, and the gates were raised ceremoniously out of the sea.
The
precise data is boring, but I can tell you that just by closing half of the inlet, you could definitely see a lowering of the water level inside the lagoon. So the Mose works. The tide was slowed.
However, there is more to the Mose than simply massive engineering. Over the years, despite the scandals attached to it, the Mose has contributed to restoring other areas of the Venetian lagoon, but even those efforts are not without controversy. In an effort to preserve the uncontaminated natural environment, environmental groups often oppose big civil works like the Venetian Mose barriers. In this case, however, the ecosystem in question is far from natural. Sediments carried by the many inland rivers originated from the lagoon itself in ancient times by sinking and consolidating below sea level. For the Mose, new concrete walls and embankments were built, and even a brand new artificial island was created at the northernmost Lido Inlet to host all the service buildings that control the barriers. On one side of the island is a lock system, a deep canal for tankers and cruise ships, and on the other side is a shallower canal leading north. However, not everyone agrees that the lagoon should be open to large ships at all. In Italy, there have already been disasters associated with large naval vessels. If one of these ships were to sink in the lagoon close to Venice, it would be catastrophic both for the environment and the residents alike.
It has made the city slave to the passing of these gigantic ships, ships that could very possibly create a legitimate threat of accident. Accidents like the ones that have unfortunately happened in this country, like on the island of Giglio with the Costa Concordia and the port of Genoa. Two extremely grave incidents that have created terrible damage.
If Mose is to be successful, it needs to be complemented by projects that will restore the lagoon's natural structure and build up its natural defenses.
The part of the project that concerns the lagoon is one of the most urgent aspects of the work because it is necessary for environmental restoration of the deteriorated areas of the lagoon, but also the shore. The moment in which the floodgates prevent the tidewaters from entering the lagoon from the sea will spread out back along the shore, and so we had to reinforce the shore for this reason.
Some of these measures include improving water quality by dredging the canals, which improves the water exchange in the inner lagoon areas, securing runoff from dumps and industrial areas, reinforcing the seawalls surrounding Venice's island and canal banks, and restoring thousands of kilometers of salt marshes. Polluted sediment was removed from canals, but where was it taken? There is concern, due to some of the corruption scandals surrounding the project, that the mud polluted by heavy metals may not have been properly disposed of. And what about the 49 kilometers of new beach? Where did it come from, and who will manage it?
There is a risk here, just like in other places, from the excavation that brings in soil from the southern part of the lagoon, which is obviously polluted, and has been since the 60s, by petrochemicals deposited in the seabed from the Marghera industrial area.
Another concern is the impact Mose closures might have on the lagoon water quality. It is the sea itself that is responsible for keeping the lagoon waters clean, since there is no sewage system and black water is released into the lagoon. Some worry that closing the lagoon more frequently could tip this delicate balance.
It's the job of the sea and the tides to clean out the lagoon. And they come into the lagoon and they leave the lagoon twice a day. Clean water comes in, picks up the waste, and takes it back out into the open sea.
Experts predict that sea levels could rise between 25 and 50 centimeters between now and the end of the century. At the same time, Venice is sinking 1 millimeter annually. The more frequent the floods, the more often Mose must be used.
The frequency of the flooding could increase significantly between now and the end of the century, so the need to close the Mose barrier could increase from the present 5 times a year to up to 100 or 150 times a year, or even 200 times. And closing the barrier so often could have an impact on the quality of the waters of the lagoon and the city itself.
University of Padua professors are proposing a companion solution to the Mose, an audacious plan to raise Venice by pumping water into a soil and rock layer beneath the city.
Our proposal is to raise the city by taking seawater and building wells 700 to 800 meters deep, and then pumping the water into the rocks at that depth. Venice will rise. We have calculated that over 10 years it could rise as much as 25 to 30 centimeters very gradually.
Critics say the Mose project may go down in history as little more than a concrete icon of corruption and waste if it's unable to protect Venice.
It doesn't give any guarantees to the city that it won't flood, because with a meter or a little over a meter of water washing up here in Piazza San Marco, the city already has problems. In truth, this won't stop.
Either way, Mose is here to stay. While Mose officials say corruption scandals were reprehensible, that does not change the fact that Mose is a naval engineering feat of incredible proportions.
The work, in my opinion, is of extraordinary seriousness and quality. You have to think that for the caissons that are 60 by 40 by 28 structures, we have tolerances of less than 1 centimeter. In the last year, we put down 18 of these caissons, one every 15 days, without erring by 1 second or 1 centimeter from our plan.
The Mose construction is permanent, together with all its accessory parts, and we'll have to live with it even if it's unable to respond to climate change, which it seems is about to happen.
Siamo tutti in attesa di questo 2017, 2016, 17.
We're all waiting in anticipation. Could be 2016, 2017, 2018. Waiting for the moment when we'll know for sure if it really works, so we can test if the project will be able to keep a significant amount of the flooding out.
Il flooding della città durante le alte maree.
After it had been pushed back several times due to the ongoing public works investigation underway, the consortium of New Venice has determined a new June 2018 date for completion of the Mose project.
The whole project is about 87% constructed. It's missing the last 3 rows of floodgates that they'll need to install by the end of 2015.
Although there is some uncertainty about how effectively Mose will protect the city of Venice, 7 billion euros have been spent, and the project is currently the best hope the city has of not being swallowed up by the very lagoon to which it owes its fame. Without doubt, the Mose project has been a marvel of engineering that has utilized the toughest machines and technologies that the maritime construction world has to offer. If it does work to save Venice from more frequent devastating floods, visitors from all over the world will still have the opportunity to admire this wondrous city of water for decades to come.